9 places on this planet where water does something it should not do. Not folklore, every one of them real, named and mappable. Not strange currents or a ghost story. Stone that grows without a volcano. Tides higher than a building, an ocean with a ceiling instead of a sky. Every one of these gets a real mechanism, checked against the record. Never a myth's comfortable ending. We start at an underwater mountain in the Atlantic, at a place scientists call the Lost City. Stone towers stand on the Atlantic seafloor and nothing built them. No coral, no creature, no human hand. The tallest rises roughly 60 meters, taller than a 15-story building, growing in total darkness. This field sits on the Atlantis Massif, a mountain off the mid-Atlantic ridge near 30 degrees north, found in the year 2000. Shallower than most vent fields, off the ridge's volcanic axis. This is one of those towers photographed at the field itself, pale carbonate rock built layer by layer, the way a cave grows stalagmites. Except underwater and on a far larger scale, with new rock still forming at its base today. This vent field is warm and alkaline, and there is no volcano under it at all. Seawater sinks into exposed mantle rock, reacts with it, and rises again as heated fluid with a pH between 9 and 11. This is one of the field's carbonate ledges up close, a shelf jutting from a tower, smaller growths branching off its underside, like frost on a window pane, built from that same reaction, one layer at a time. Some vent fields nearby run on magma, acidic and near the boiling point of water. This one runs on nothing but rock and cold seawater, alkaline instead of acidic, and measured near 91 degrees Celsius at its single hottest vent. Rock and seawater together are the thing making the towers. This wider seafloor view shows a whole cluster of them rising from the massif at once, evidence the reaction keeps running across the entire field. Dating the carbonate puts this field at a minimum age of 120,000 years, still growing in places, dormant elsewhere. Fully explained, seawater, rock and time, no magma required. The Sargasso Sea is the only sea on Earth with no coast at all. It covers roughly 2 million square miles of the North Atlantic, and not 1 mile of it touches land. Every other named sea on the planet is defined by a shoreline somewhere around it. This one is defined entirely by moving water. 4 ocean currents that circle around it and never quite let it go. This is Sargassum itself, the floating brown algae the sea is named for, photographed clogging a shallow bay. Out in open water, it drifts in loose mats for its entire life, never anchoring to a seafloor at all. Those 4 currents are the Gulf Stream, the North Atlantic Current, the Canary Current, and the North Atlantic Equatorial Current, together forming a slow clockwise gyre. Whatever drifts into the middle tends to stay there. A newer, separate phenomenon has grown alongside the sea. The Great Atlantic Sargassum Belt, a larger bloom stretching from West Africa toward the Gulf of Mexico. It reached an estimated 20 million tons in 2018 and passed 22 million by 2022. This is that same algae at close range. Its small, round, gas-filled floats clearly visible, the exact structure that keeps every mat buoyant at the surface indefinitely, with nothing anchoring it below. Its borders are 4 moving currents, and they move. The gyre shifts with the seasons, so the sea's shape and size change year to year with no single fixed edge. European and American eels are believed to travel here to spawn, but no adult has ever been observed doing it, only larvae found drifting after. The Sargasso Sea stays genuinely disputed. Tags track adults arriving, none seen laying an egg. The Bay of Fundy's tide rises higher than a 3-story building. At its most extreme point, the water level climbs and falls by roughly 16 meters, about 53 feet, twice a day. That is the largest tidal range recorded anywhere on Earth, measured at Burnt Coat Head in the bay's inner basin. Twice daily, an entire coastline is redrawn between full and empty. This is Hopewell Rocks at high tide, the same rock formation you are about to see again. Water risen well up its base, small boats floating at a level that would leave them stranded on dry ground only hours later. This is that identical formation only hours later, at low tide, the same rock, now standing on exposed seabed you could walk across on foot, the water it was floating in gone entirely. The tides are that big because of resonance, not because the bay itself is unusually large. The Bay of Fundy and the Gulf of Maine together form a basin whose natural sloshing period nearly matches the tide's own rhythm. Push any body of water at close to its own natural frequency and the swing amplifies, the same way pushing a swing at the right moment sends it higher with no extra force. Here, that amplification happens twice every day. This is the Minas Basin, the innermost and most extreme part of the bay, its tidal flat exposed for miles at low water. Hours later, this entire visible ground will sit under water again, the cycle repeating on schedule. The mechanism here is fully explained. An ordinary tide, amplified by a rare coincidence of shape and timing, not by the bay's size. Change that timing and the record disappears with it. Under the Ross ice shelf, there is an ocean with a ceiling instead of a surface. Floating ice covers roughly 500,000 square kilometers of open seawater, an area comparable to the size of France. None of that ice is frozen to the ground beneath it. The whole shelf floats on the ocean, rising and falling gently with the tide exactly the way a boat would, just built from ice instead of hull. This is the shelf's own edge, where the floating ice meets open water directly. Broken ice chunks and a sheer cliff face, the visible boundary between the ceiling above and the ocean cavity it covers. At one studied borehole drilled decades ago, roughly 420 meters of solid ice sat over a water column about 237 meters deep before reaching open ocean. That gap varies by location, from only tens of meters to past 700 elsewhere. Sunlight cannot reach any of that water. Whatever lives down there survives entirely on currents flowing in from the open ocean at the shelf's outer edge, carrying nutrients hundreds of kilometers under solid ice to reach it. This is a research camp on the ice above, drilling down through the shelf to sample the ocean and seafloor sediment beneath it. One of several projects that have reached this hidden cavity with equipment lowered from the surface. That cavity is the size of a country and it circulates. Measurements through boreholes like this one show currents moving steadily beneath the ice, carrying heat and nutrients across the hidden ocean. Exactly how much warmer water reaches that cavity and how fast it thins the ice from below stays genuinely disputed among researchers, with different boreholes giving different answers on the same shelf. A hole opened in Antarctic sea ice the size of a small country, in the middle of the pack, nowhere near open water. In September 2017, it began at about 9,300 square kilometers and kept growing. By early December that year, it had grown to roughly 298,000 square kilometers, comparable to South Carolina, open ocean surrounded on every side by unbroken ice. This is that hole photographed from orbit, a dark patch of open water surrounded entirely by white pack ice, sitting directly above an underwater mountain called Maud Rise, roughly 100 kilometers across at its base. The mechanism is deep convection. Warmer water from far below occasionally rises past that seamount and reaches the surface, carrying enough heat to melt a hole in ice that should otherwise stay solid all winter. This exact feature had only ever been seen once before, decades earlier, and even scientists tracking it by satellite in real time in 2017 were reportedly surprised to see it return at all after so long. This is a much smaller version of the same idea, an ordinary crack called a lead, opening briefly in Antarctic pack ice, the aircraft that photographed it casting its own shadow across the exposed water below. It opened in the 1970s, then essentially not again for 40 years. Satellites recorded this same polynya recurring across 3 winters, 1974 through 1976, averaging roughly 250,000 square kilometers each time. Then it stopped returning until 2016, and researchers do not fully agree why it comes back only in some years. The mechanism is known, its actual schedule stays completely open. Those 5 are the deep dives, verified places, verified mechanisms, checked against the record. 4 more deserve real airtime too. Shorter stories, same rule. Only what is actually documented gets to stay on screen. This is Lake Nyos today in Cameroon, with an engineered pipe now venting carbon dioxide from its depths continuously, on purpose, so the gas that once built up here can never accumulate the same way again. On the night of 21st August 1986, this lake released an estimated 1 to 1.3 cubic kilometers of carbon dioxide in a single burst. Denser than air, the cloud hugged the ground and rolled downhill for miles, silently displacing breathable air. The toll, 1,746 people, plus an estimated 3,500 livestock, with no warning any of it was coming. The mechanism is called a limnic eruption, and it is well understood. A lake can store enormous volumes of gas at depth for years, until something disturbs it enough to release it all at once. At Taylor Glacier in Antarctica, a bright red liquid seeps out of solid ice and flows downhill into a frozen lake, staining the glacier's face the color of rust against pure white ice on every side of it. This is that outflow itself, photographed at the glacier's face, with a research tent pitched nearby for scale. Iron-rich brine, stained deep red the moment it meets oxygen at the surface. The brine feeding it is hypothesized to have been sealed inside the glacier for over 1 million years. A 2017 radar study traced its actual path, a narrow channel of brine running through solid ice, kept liquid by its own salt and the heat ice releases as it forms. At Thingvellir in Iceland, a narrow fissure splits open exactly where 2 tectonic plates are slowly pulling apart, filled with water so clear that visibility runs to roughly 100 meters in every direction. This is that fissure itself, clear blue-green water held between 2 walls of bare rock, cold enough and clean enough that almost nothing grows in it to cloud the view. That water started as snowmelt on a glacier roughly 30 years earlier, filtering the entire way here through porous volcanic rock underground, arriving with almost nothing left in it but the water itself. In a valley in Antarctica, cold enough to freeze nearly everything else solid, one shallow pond stays liquid through the entire winter, often carrying no ice at all, even at the coldest temperatures recorded nearby. This is that pond itself, sitting in the floor of the right valley, shallow enough to see the salt crusting its edges, a body of water that should not exist in liquid form at these temperatures at all. Its water is over 40% salt by weight, mostly calcium chloride, and that concentration alone drives its freezing point down far enough that it has been recorded staying liquid to roughly -50 degrees Celsius. 9 real places, 9 real mechanisms, checked against the record. The lost city grows carbonate towers from rock and seawater alone, no volcano required. The Sargasso Sea has no coast at all, and still will not show anyone an eel actually spawning. The Bay of Fundy's tides are the largest on Earth because of resonance, not size. Under the Ross ice shelf sits a genuine ocean, ceiling instead of surface, and researchers still argue how fast it is changing. And the moored rise polynya opened a hole in the ice the size of a country, then did not return for 40 years, and nobody fully knows why. If real places that break water's own rules are worth your time, subscribe. There are more of them waiting, and at least one of these 9 still does not have a settled answer.